Now we'll try to apply properties of similar polygons, similarity theorem for perimeters, and then areas of similar polygons as well. Okay, so number one, you want to find the value of x. So x is a side length, the longer side length of the smaller rectangle, and you're given that these two polygons are similar. So the shorter side of the rectangle in the larger rectangle corresponds with the shorter side in the smaller rectangle. The similarity ratio would be 2 to 3. And then I could set up a proportion in order to find the value of x. So if the similarity ratio is 2 to 3, then 2 is to 3 as x is to 7. And then I can solve this proportion by cross multiplying. If you remember how to solve proportions, 2 times 7 is 14. That's actually equal to 3 times x. Maybe you just remember or were taught you cross multiply and divide, but this is the equation that you actually set up. So x is equal to, if you divide each side by 3, 14 over 3, or that would equal 4 2/3. So that's the value of x. I'm just going to leave it as a fraction like that. I'm not going to write it as a decimal. Okay. Then on number 2, I could do something similar. I have to look at what the similar sides are though. So 20 corresponds with 8. 12 actually corresponds with 30, and then x corresponds with the 25 here. So there's a couple of different things that you could set up in order to find the value of x. Again, x corresponds with 25. You could set up 25 over x, since those two sides correspond, is equal to, one of the things that you could set it equal to is 30 over 12. You could also set it equal to 20 over 8. You can even simplify this ratio as well. You can solve it with the unsimplified ratio. It'd still give you the same value of x. 30 over 12, you can simplify that by dividing both the numerator and the denominator by, what's the greatest common factor? 6. So 30 divided by 6 is 5. 12 divided by 6 is 2. So 5 over 2. Now I can cross multiply. 25 times 2 is 50. And then divided by 5, so x is equal to 10. If I left it the way that I had it originally, what did I have originally? 30 over 12. I could still cross multiply and divide to solve that for x. So I can multiply 25 by 12, 300, and then if you divide that by 30, you still get x is equal to 10. Okay, I could have also set up 25 over x is equal to 20 over 8 and still get x is equal to 10. Okay, moving on to number 3. It says find the scale factor of, polygon ABCDE to polygon KLMNP. It tells you that the two polygons are similar. So you have to look at a pair of corresponding sides. From ABCDE to KLMNP, so ABCDE 2 to 3 would be a scale factor for those two similar polygons. And then it says find the scale factor from, and it's just switching things around. So it would be 3 to 2. Find the values of x, y, and z. So to find the value of x, x corresponds with this side length, that's 1. Okay. I could set up a couple of different things. If I do x over 1, that's a side in KLMNP over a side in ABCDE. So if I set up the corresponding sides, 3 and 2, I have to put in the numerator the 3, because that's a side in KLMNP over 2. Cross multiply, so 3 times 1 is 3, divided by 2, 3 halves. X is equal to 3 halves, or 1 1/2. Either way. Find the value of y. Y corresponds with 3 square root 2. So I could set up a similar proportion here. 3 over 2, those two sides still correspond, is equal to y over 3 square root 2. So I still want to cross multiply. 3 times 3 square root 2 is actually 9 square root 2. You can only multiply the 3 and the 3 here. You can't multiply the 3 by the 2 because that's underneath the square root or radical. So 9 square root 2 divided by 2. I'm just going to leave it like that. You can't divide this 2 by this 2 because one's underneath the radical The other is not. Sorry, you couldn't see that. Okay, now you can. And then lastly, to find the value of z, z is angle A. Angle A corresponds with angle K, so z should be 45 degrees. And then we'll continue this in the next part.